This is chapter 12, section 12.4, discrete probability models. There are two types of models, discrete and continuous. In this section, I am going to discuss both of them. First, what is the discrete probability models? If S is a countable set, this refers to a discrete probability model. Can you give me an example for the countable set? I say S equal 1, 2, 3, 4. This is a countable set. If I give you some like this, S is each numbers between 0 and 1. Is this countable? No. Why? How many numbers between 0 and 1? Infinitely many numbers. So that is not countable. So then it should be continuous. I will explain that later. Next, you should know how to assign the probabilities for discrete models. First, you list the probabilities of all the individual outcomes. These probabilities should be between 0 and 1. We already know now this one. We learned this one in the previous video. Probability is always between 0 and 1. Minimum probability is 0. The maximum is 1. And also summation of all probabilities of that experiment should be exactly 1. Then how do we find the probability of any event? The probability of any event is the sum of the probabilities of the outcomes making up the event. Let me explain this using this example 11. Choose an adult in the United States at random and ask how many days per week do you lift weights? Call the response X for short. If I ask this question from you, what should be your answer? Maybe 1 day, or twice a week, or it means 2 days, or 5 days. But no one says 2.3 days, or 5.6 days. We don't use decimals to tell the number of days. It is clear X values goes from 0 to 7. And this is countable. Then how do we write the probabilities? According to the experiment, we write the probabilities here. Probability x equal 1 is 0.06. Probability x equal 4 is 0.04. And similarly, you see all the probabilities. Summation of this probability is 1. Therefore, we can say this is a legitimate probability model. Verify that this is a legitimate finite probability model. Yes, I just explained this. How do we verify this is legitimate finite probability models? First, add these probabilities. Summation of these probabilities is what? Let me check. 0.04, 0.02, 0.01 plus 0.02. This is 1. Therefore, yes, this is legitimate finite probability model. Then second, describe the event x less than 4. For x less than 4, how do we describe this event? We can say lifted weights less than 4 days. Next, asking probability x less than 4. Go back to the note. How do we find the probability? Sum of the probabilities of the outcomes making up the event. Right. First understand the value of x. X less than 4. This is equal in the discrete model. X less than or equal 3. So x values should be 0, 1, 2, 3. Therefore, how do we find the probability x less than 4? We can write the same one, this equal x less than or equal 3. Again, this is true only for discrete case or discrete models. Probability x equals 0 plus probability x equal 1 plus probability x equal 2 plus probability x equal 3. Then we can find the probabilities from the table. This is 0.06, this is 0.06, the last one also 0.06. So this is 0.91. That is the probability x less than 4. Then third, express the event lifted weights at least once. At least once, I say x greater than or equal 1. At least once mean x equal 1, 2, 3, 4, 5, 6, 7. Then how do we find the probability of this? X greater than equal 1. So we should add all the probabilities of these numbers, right? X equal 1 plus probability x equal 2, so on. The last one, probability x equal 7. You know there is another way to find this. How do we do that? We can use the fourth axiom in the last video I explained. That is complement rule. How do we use the complement rule? Let me get this number line again, 0, 1, 2, 3 up to 7 here. So x greater than equal 1 mean we use 1, 2, 3 up to 7. All numbers up to 7, right? Then what are the left? We have only 0 here. Then we can write this 1 minus probability x less than 1. Please pay attention here. This is greater than or equal 1. Therefore, we use here strictly less than 1. Then 1 minus, what are the numbers less than 1? We know only we have 0. Therefore, probability x equal 0. Then 1 minus probability x equals 0 is 73. Then answer is 0.27. Now, continuous probability models. What is the continuous probability models? A continuous probability model assigns probabilities as area under a density curve. The area under the curve and above any range of values is the probability of an outcome in that range. We discussed this one under chapter 3. Let me remind you. X-axis and y-axis. So this is the probability density curve. How do we find the probabilities between A and B? The area under the curve and between A and B. This is always above the x-axis. So this is the probability. I say x greater than A and less than B. Here actually we consider each number between A and B. How many numbers in between A and B? Infinitely many numbers. Therefore, we consider area for the probabilities. This is the continuous case. Let me explain again difference between discrete and continuous case. So suppose instead of A, I use as an example numbers. Here I say 2, this one 8. If we consider discrete case 3, 4, 5, 6, 7, 8, we consider probabilities only of these numbers. X equal 2, x equal 3, x equal 4, so on. But in continuous case, we consider each numbers in between 2 and 8. How many numbers? Infinitely many. So then we use the area to find the probabilities. Now let me explain this example. Example number 12. The normal distribution with mean mu 25 and standard deviation 6.4. Right. Then we use x. So x has normal distribution. Mean is 25. Sigma is 6.4. If you draw the curve like the chapter 3, we can draw this is 25, right? So what is the question? First one is asking, write the event the student chosen has a score 35 or higher in terms of x. So x greater than or equal 35. That is the event. Then asking to find the probability of this event. How do we find the probability? Probability x greater than equal 35. Now we go back to the chapter 3. Right. When you have greater than or equal, what you do, you make this greater than or equal to less than or equal, right? 1 minus probability x less than or equal 35. That is the first step. Greater than or equal, here convert to the less than or equal. How do we convert? Always 1 minus probability x less than or equal that number. Then what is the next? We convert x to the z. 1 minus probability z less than or equal. How do we convert to the z? Could you remember z value? Z equal x minus mu over sigma. What is x here? 35. Mu is the mean. 25. Sigma is 6.4. This is 1.562. I first find the answer for 3 decimals, then I round to the 2 decimals. Because for the z value in the table, we can use only for 2 decimals. Probability z less than or equal 1.56 then. So 1 minus, how do we find the probability z less than or equal 1.56? Now we use the z table. This is the z table we use. Pay attention to this graph. This always we take the less than area. That's the reason we always write 1 minus probability z less than or equal something. So 1.56, 1.5 here and 6 is here. Therefore, the number is at the intersection 0.94 or 6. So this probability 0.94 or 6, then 10, 6, 4, 9, 9, 4, 5, 9, 9, 0, that is 0.0594.